This might be a very short video, but we're going to be doing some practice problems on complex numbers. So what makes a number complex? Well, there's something called imaginary numbers. And all that is, well, because we don't know what the square root of -1 is, we just notate that as I. Okay, and that's all this is the definition. That's all it is, really. So we know that I squared is actually -1. And I to the fourth would be 1, actually. So you might need to know those in some of these problems. I don't think you need to know it in this specific. Actually, no, we do need it. Okay, never mind. But this is the definition. So that I squared, when you square a square root, it goes away. And the I to the fourth, well, if we square this, then -1 squared is 1. Okay, so that's just simple properties. There is a dichotomy, though, that square root of square root of -1 times square root of -1, isn't that just square root of -1 times -1 by properties of radicals? So why is that different than this? So there's this dichotomy, if that's the right word to use. There's contradiction. But by definition, I squared is -1. Okay. All right. So hopefully that didn't confuse you, but just if you didn't realize that this is also technically I squared, but by definition, that's not correct. All right. Anyway, which of the following is equal to this? Okay. So go ahead and try it for yourself first, as always, before you come see how I solve it. Well, square root of -1 is I. Square root of -4 is square root of 4 times square root of -1, which is minus I root 4. And this is square root of -9 is square root of -1 times square root of 9, which is I root 3. Sorry, I root 9. Okay, what's root 4? That's 2. What's root 9? That's 3. So that's what I was thinking, 3. Okay, so what's I minus 2I plus 3i? Well, that's 4i's minus 2i's, so that's 2i. Okay, next, which of the following is equal to this? Well, what is square root of -2 times square root of -8? We can use properties, or we can write it as I root 2 times I root 8. Right? So what is I times I? That's I squared, which is -1. So -1 times square root of 16. Okay, which is -1 times 4, which is -4. That's the answer. So this is exactly what I was saying here. Be careful that it's not D, actually. Okay? So when you combine inside one radical, like I did up here, then you would have gotten square root of positive 16, which is 4. But that's not the answer. The answer is C, actually. So what's the difference here, or the takeaway? Those properties, it seems like, only work when it's not a negative number. Okay? Which of the following complex numbers is equal to this? Okay, so this is similar to why we rationalize things with square root. Like, if you remember in the other section, it was like, we don't like not we, but for some reason, when they teach you this, they don't like square roots at the bottom of fractions. Similarly, they don't like when I is at the bottom. Okay, so how do we remove an I from the bottom? We multiply by the conjugate. Same exact concept with radicals. So instead of 3 plus I, we want to multiply by 3 minus I on the top and the bottom. So on the top, we would get 3 minus I squared. Okay, we'll leave that alone first. The bottom, we would have a difference of 2 squared. So it'll be 9 minus I squared, What's I squared? That's negative 1. 9 minus negative 1, that's 10. Okay? And if we expand the top out, it would be 9 minus 6i plus I squared. Okay? And here, well, I squared again is negative 1, so 9 minus 1 is 8. So 8 minus 6i over 10. And we just simplify from here. That would be 4 over 5 minus 3i over 5. Answer is D. Okay. Next, which of the following is equal to this? So let's just distribute this half to both these terms and this a third to both these terms, or the minus 1/3 to both those terms. So it'll be 5 over 2i minus 3 over 2 minus 4 over 3i minus 5 over 3. Okay? So let's group the like terms together. 5 over 2i minus 4/3 I. Well, let's rewrite this in terms of a denominator of 6. So it'll be what's 15i. And then this would be 8 over 3i, right? Similarly, this would be times 3, so that's 9 over 2. This is times 2, so 10 over 3. Okay? 15 over 6 minus, this should be 8 over, these all should be 6. I don't know what I'm doing. Sorry for lots of errors on this video so far. Okay, so 15 minus 8, that's 7 over 6i. And then this is minus 19 over 6. And that's the answer. Let me double check. 7 over 6i minus, yep. Okay. So the key here was to distribute and then combine like terms. Nothing new. If this were x, you would do the exact same thing. But here it's just I. Okay? If 4 plus I quantity squared is a plus bi, what is the value of a plus b? Okay? Let's expand this. It'll be, let's use the formula, 16 plus 8i plus I squared. What's I squared? That's negative 1. So 16 minus 1 is 15. So my A is 15. My B is 8. So 15 plus 8, 23. Okay? Last one. If the expression this guy is rewritten in the form A plus BI, in which A and B are real numbers, what is the value of A plus B? So we need to rationalize this again. So we're going to use the conjugates again. So it'll be the conjugate of 1 minus 2i is 1 plus 2i. Okay? Now, on the bottom, we would get what's 1 minus 4i squared. Right? Difference of two squares. That's why we need to know that formula really well. And the top, we would get what? 3 plus 6i minus I, and then minus 2i squared. Okay? So, this is on the bottom, I squared is negative 1, right? Times negative 4, that becomes a plus 4. So 4 plus 1, that's 5 on the bottom. Okay? Now on the top, what do we get? We get, so I squared again is negative 1. So this becomes a plus 2, plus the 3, that's 5. And then this is plus 5i. Okay, so this is just 1 plus 1i, or 1 plus I. A plus b, that is 2. Because A is 1, B is 1. Okay, and that's it for this video. So as you can see, you just really need to know the definition of I and I squared. Okay, otherwise it's things that you've done before. Like conjugates. It's similar to the radicals. This is the square formula. Perfect square formula. You need to know that. Difference of two squares. When you're rationalizing, you need to know that. So it's same things as before. Here, nothing different if this were x in terms of simplifying. Okay? So the additional new knowledge you needed to know was square root of negative 1 is I, and I squared is negative 1. Okay? And again, this one, you have to be careful. You can't use those properties of radicals here because it's or let me back up one more time. We can't use them because what is square root of negative 2? We don't know that. Or it's square root of 2 times I, technically. But if you punch this into calculate, you can't do that. So you can't just combine two things that kind of don't work, per se. So you can't just combine this into a root 16. That's the key takeaway for this one. Hopefully that helps you think of this if you got stuck or confused why it's not D. Okay? Please like and subscribe as always if this helped you in any way. And in the next video, we'll be doing the chapter test, meaning more practice problems. So hopefully I see you there. Bye.